house has been robbed. The detective surveys the scene. A broken window, footprints in the garden, a missing necklace, a fingerprint on the jewelry box. Two theories are on the table. Theory 1, a single thief broke the window, walked through the garden, and took the necklace. Theory 2, 12 separate conspirators were involved. One broke the window, another independently made footprints in the garden, a third took the necklace, a fourth planted a fingerprint, and so on. Each clue planted by a different person, coordinated to make it look like a single burglary. Here's the uncomfortable fact. Both theories fit the evidence perfectly. Every clue is accounted for on both theories. If all you cared about was, does the theory explain the data, you'd have no way to choose. And yet, every detective on Earth, every juror, every rational person prefers the first theory, instantly, without hesitation. Why? What exactly makes the one thief theory better when both theories fit all the available evidence? If you answer that question, really answer it, you understand something deep about how all human knowledge works, and you're holding the key to chapter 3 of Richard Swinburne's The Existence of God, the chapter where he lays down the rules of evidence for the entire book. Because here's where this is headed. Swinburne is going to argue that the same standard that favors one thief over 12 conspirators, the standard at work in every scientific lab and every courtroom, is the standard by which we should judge the hypothesis that God exists. Today, the rules of the game, part 2. Let's get into it. Where are we in the series? In the first lecture, we saw Swinburne's overall strategy. Treat the arguments for God as inductive arguments, arguments that raise the probability of God's existence, and then ask whether the cumulative case makes theism more probable than not. In the second lecture, we distinguished two kinds of explanation. Scientific explanation works through initial conditions and laws of nature. Personal explanation works through human agents, intentions, and powers. And we saw that personal explanation cannot be reduced to scientific explanation. It is its own irreducible way of making sense of the world. But that left a huge question hanging. Fine, there are two kinds of explanation, but when should you believe a proposed explanation? What separates a good explanation from a just-so story? If I explain the noises in my attic by squirrels, and my neighbor explains them by ghost, we've both offered explanation. What makes one explanation justified and another explanation unjustified? That's today's question, and Swinburne's answer applies, this is the crucial move, to scientific and personal explanations alike. Here's Swinburne's core claim. A proposed explanation is probably true to the extent that it scores well on two factors. Factor 1, explanatory power. The hypothesis should make the evidence likely. If your hypothesis is true, the stuff we actually observe should be the kind of stuff that you would expect to observe. And, this is the part people forget, the evidence should be unlikely otherwise. A theory gets credit for predicting things that would be surprising without it. Think about the fingerprint. The fingerprint on the jewelry box supports the butler did it only if the fingerprint is more likely on that hypothesis than it would be otherwise. If the butler polishes that jewelry box every single day, if his fingerprints would be there anyway, the fingerprints tell you nothing. Evidence counts in favor of a theory only when the theory makes it more expected than it would be otherwise. Factor 2, prior probability. Some hypotheses are more plausible than others before you even look at the specific evidence. And what determines that? Mainly three things: how well the hypothesis fits with everything else we know about the world, how simple it is, and to a lesser degree, how modest its scope is, how much or little it tries to explain. Explanatory power and prior probability. Fit the data and be plausible in yourself. Every justified explanation in physics, in history, in the courtroom, in everyday life scores well on both. Now, of those ingredients, one is going to steal the show today, because it turns out that one of them is quietly holding up the entire edifice of human knowledge, and almost no one notices it. Let me show you why simplicity matters, with an example that convinced me. Johannes Kepler, early 17th century, is studying the motion of Mars. He has set out observations, think of them as dots on a chart, positions of Mars at various times. His job, figure out the path Mars is following so he can predict where it will be next. So connect the dots. What curve does Mars trace? Kepler's answer, famously, was an ellipse. Beautiful, clean, historic. Here's the problem. Through any finite set of dots, you can draw infinitely many curves. Not just an ellipse, a spiral that hugs the ellipse perfectly for the observed period and then veers off next year, a path that traces ever larger loops, a wild, contorted scribble that happens to pass through every observed single point and then does something insane. Every one of those curves fits the data perfectly. Every one of them explains the observations. If fitting the data were the only standard, all of them would be equally credible. And prediction would be impossible because the curves all disagree about what's going to happen tomorrow. But no one, not Kepler, not any serious scientist since, takes the contorted curves seriously. Why not? They fit the observations exactly as well as the ellipse does. There's only one honest answer. The answer is simpler. We treat simplicity as a mark of truth, not just of convenience, not just of beauty. When infinitely many theories fit the data equally well, we believe the simplest one. This isn't a quirk of astronomy, it's completely general. Any finite body of evidence in any field whatsoever can be fit by infinitely many incompatible theories. The data never speak for themselves. Something has to break the tie. And the thing that breaks the tie through science and ordinary life is simplicity. Swinburne has a slogan for this. The simple is the sign of the true. Hold on to that phrase. It is, in many ways, the motto of the entire book. And notice that this is exactly what's going on with our detective. One thief versus 12 coordinated conspirators, both fit the clues. We believe the one thief theory because it posits one agent instead of 12. It's the ellipse, not the scribble. Okay, but what is simplicity? Simplicity can sound hopelessly vague or worse, subjective. Simple to whom? Swinburne actually gets specific about this. A theory is simpler, he says, to the extent that it postulates fewer things, one thief, not 12, one unseen planet tugging on a wobbly star, not 5, fewer kinds of things. A physics with one family of particles is simpler than a physics with a zoo of unrelated ones. Fewer properties and more familiar ones, properties closer to what we actually observe, and mathematically simpler laws. Here's my favorite example. Newton says gravity weakens with a square of the distance, an exponent of exactly 2. Now consider a rival theory. Gravity weakens with the distance to the power of 2.000, continue on with 100 zeros, 1. For any measurement we could ever make, the two theories are indistinguishable. Both fit all the data, but nobody would take the second seriously for a moment. An exponent of 2 is simple. An exponent of 2.00 with 100 zeros and then 1 is a monstrosity. We believe the simple law. Now, one more wrinkle. I'm flagging this one deliberately because it's going to matter enormously later in the series. Infinity is simple. The idea is that infinity has no finite limit. It sounds backward to say that infinity is simple. Surely infinite anything is extravagant. But think about how science actually behaves. Before anyone could measure the speed of light, the natural default was to suppose light traveled infinitely fast. Not that it traveled exactly at, say, 301,000 kilometers per second. Why? Because a particular huge finite number is arbitrary. It cries out for explanation. Why that number and not another? Infinity, by contrast, is clean. It's the absence of an arbitrary limit. You can state it without specifying any particular quantity at all. 0 and infinity are the two simplest values a quantity can take. The awkward, complicated hypotheses are the ones in between, the ones that have to say why exactly this much and not any more. File that away. When we get to chapter 5, and Swinburne argues that a God with infinite power and infinite knowledge is a supremely simple hypothesis, simpler than a God with very large but finite powers. This is the principle that he'll be drawing. If that sounds crazy to you now, good, sit with it. It fell out of the philosophy of science, not the philosophy of religion. Now let's put the two factors together. And yes, I'm going to show you one equation, just one, and I promise you already believe it. You use it every day without knowing its name. It's called Bayes' theorem. And here's what it says. The probability of a hypothesis given a piece of evidence E and some background knowledge K is equal to a specific relation between probabilities. You have, on the one hand, the probability of the evidence given the hypothesis and K, how likely that hypothesis is given your evidence and your background knowledge. That is divided by the probability of the evidence just given the background knowledge without the hypothesis. And that fraction is multiplied by the probability of the hypothesis given your background information. So let's translate every piece into English. H is your hypothesis, the butler did it. E is the evidence, the fingerprint. K is the background knowledge, everything else you know about the world. The left side, the probability of H given E and K, is what you want. How probable is the hypothesis given the evidence? Philosophers call this quantity the posterior probability, your confidence in the hypothesis after the evidence comes in. The right side says that confidence is the product of exactly two things. The probability of H given K is the prior probability, how plausible the hypothesis is before you consider the evidence. Philosophers, that's factor 2 from earlier, fit with the background evidence, and above all, simplicity. And the fraction, probability of E given H and K, over probability of E given K, is explanatory power, factor 1. This is sometimes referred to as the Bayes factor. The top asks, how expected is the evidence if the hypothesis is true? The bottom asks, how expected is the evidence anyway? The more the hypothesis makes surprising evidence unsurprising, the bigger that fraction gets, and the more the evidence boosts your confidence. Posterior equals explanatory power times prior. Fit the data and be plausible in yourself, multiplied together. That's the whole theorem. Everything we've said today is packed into that one line. And here's a beautiful consequence that falls straight out of it. Philosophers call it the relevance criterion. Evidence E confirms a hypothesis H if and only if the evidence is more likely if the hypothesis is true than if it's false. That's the fingerprint principle from earlier, now stated exactly. The butler's fingerprint confirms his guilt only if it's more likely to be there given guilt than given innocence. If he polishes the box daily, equally likely either way. Confirmation 0. Every juror already reasons this way. Bayes' theorem just makes the reasoning precise. Before we bring this home, one objection needs handling, because you will hear it constantly in debates about God. The objection goes, real science makes testable predictions. You formulate the theory, you predict something new, you wait, you check. The God hypothesis doesn't predict anything checkable next Tuesday. Therefore, it can't be confirmed. Therefore, it's not rational to believe it. Sounds rigorous, but notice something about Bayes' theorem. Nothing in it, nothing, cares about when the evidence is discovered. Before the hypothesis was formulated, after, during, the theorem is silent. All that matters is the logical relationship. How probable is the evidence given the hypothesis? And real science agrees. Newton's theory of motion was accepted as a towering achievement in the late 17th century. And what sealed the case wasn't a novel prediction that Newton made and everyone waited around to check. It was that four stunningly simple laws unified evidence humanity already possessed. The orbits of the planets, the fall of the apples, the swing of the pendulums, the rhythm of the tides, old evidence, known for decades, for centuries. The theory was confirmed because it explained it all, simply, not because it called its shot in advance. So when we come to weigh the hypothesis of theism, the question will not be, does God predict something checkable next Tuesday? The question will be the Newton question. Does the hypothesis render the great familiar already known facts that a universe exists at all, that it runs on elegant laws, that it contains conscious beings, more expected than they would be otherwise? That's not a lowering of scientific standards for God's benefit. It's the same standard Newton was held to. Now for the move that makes the chapter more than just philosophy of science. All the criteria, Swinburne argues, apply to personal explanation too. In fact, you've been applying them your entire life. How do you know your friends have minds? Seriously, how? You can't see a mind. All you can observe is behavior. Bodies moving, sounds coming out of mouths. On the basis of that, you attribute to other people beliefs, intentions, powers, an entire invisible life. That's a hypothesis. And look at how you handle it. You assume other people are basically like you, that they roughly see what you see, want the kinds of things you want, can do the kinds of things you can do. Philosophers call that the principle of charity, and it's really simplicity in disguise. Their minds work like mine is a far simpler theory than a bespoke psychology for every stranger. And you assume people are stable, that they don't randomly reshuffle their beliefs and intentions between breakfast and lunch. Simplicity again. And the hypothesis earns its keep through explanatory power. It makes people's behavior expected. If your friend intends to mail a letter and believes the mailbox is to the left, she'll walk to the left. If she keeps walking on the right, something in your theory of her has to give. Prior probability, explanatory power. The same two factors now applied to minds. And once you see that, you can ask a deliciously strange question. Could evidence ever justify believing in a person very unlike us? Swinburne goes straight to the example of poltergeists. Suppose books and chairs and inkwells start flying around my room. Could I ever be justified in explaining that by an invisible disembodied agent? In principle, yes. If the hypothesis scored well on the two factors. Suppose the objects don't fly randomly. They arrange themselves into warnings addressed to a particular person. They strike someone who, as it happened, gravely wronged a man who died in the house. Now the poltergeist hypothesis is doing real work, postulating one agent with stable, humanly intelligible intentions that make otherwise wildly improbable events expected. And crucially, it wins only if no ordinary rival explanation explains the phenomena better. If a hurricane or a hidden prankster with fishing wire covers the evidence, the poltergeist hypothesis loses on the priors, and it should lose. The point of the example isn't that poltergeists exist. They almost certainly don't. The point is that explanations involving unusual, even disembodied agents are not ruled out by fiat. They're ruled out, or ruled in, by the same two-factor testing as everything else. There's no separate rulebook. And this brings us to God. Theism, remember, is a hypothesis of a personal explanation. An agent, God with intentions and powers, who brings about the universe. So it gets judged by the two factors like everything else. But theism has one feature that makes it unlike the poltergeist, unlike the butler, unlike anything local. Its scope is maximal. It doesn't purport to explain the going-ons in one haunted room. It purports to explain everything that exists apart from God. And that has a consequence that's easy to miss and hugely important. Remember that prior probability has three ingredients: fit with the background evidence, simplicity, and scope. But when a hypothesis tries to explain everything, there is no background knowledge left over for it to fit with. Background knowledge is what you must hold fixed while explaining something else. The detective holds fixed how fingerprints work while investigating the burglary. But when the thing being explained is all of it, the whole contingent world, nothing is held fixed. Everything is on the table as evidence. You might think that's cheating, that theism dodges a test other theories have to pass. It isn't. A physical theory of everything isn't in exactly the same book. Any hypothesis of total scope, theistic, physicalist, whatever, has no external background to fit. Its prior probability has to come from what's left. And what's left, overwhelmingly, is simplicity. So here is where the whole book now stands. The probability of theism, given the evidence, hangs on two questions. The first question, is theism simple? Is there's one God of infinite power, infinite knowledge, perfect freedom, a simple hypothesis? One entity, one kind, with those suspiciously clean infinite values we talked about? Or is it complexity smuggled in robes? That's chapter 5. And it's where the infinity is simple principle becomes load-bearing. Question 2. Does theism have explanatory power? Does the existence of God make the actual evidence, a universe, laws, fine-tuning, consciousness, notably more expected than it would be otherwise? That's the burden of the whole middle part of the book. One argument at a time. We'll get there. Prior probability and explanatory power. The detective standard. Newton's standard. And now, the standard by which we're going to judge the hypothesis that there's a God. Okay, let's gather it up. Every justified explanation, scientific or personal, rests on two factors: prior probability and explanatory power. The curve-fitting problem shows that data alone can never pick the right theory. Infinitely many theories always fit. Simplicity breaks the tie everywhere, always. The simple is the sign of the true. Simplicity means fewer things, fewer kinds, simpler laws, and surprisingly, infinite values are simpler than arbitrary finite values. Bayes' theorem welds the two factors into one engine. Posterior probability equals explanatory power times prior probability. And it tells us a theory needn't call its shots in advance. Explaining old, familiar evidence simply as Newton did is confirmation enough. The same standards govern our belief in other minds, and they govern a poltergeist, and they govern God. No special pleading in either direction. And theism, as the hypothesis of maximal scope, will stand or fall on the two questions now squarely before us. Is it a simple hypothesis, and what does it lead us to expect? But before we can cash out any of that, there's a prior question, maybe the deepest one in the whole book. Does everything need an explanation in the first place? When is it rational to say, this is just a brute fact? It has no explanation. It just is. Because the atheist has a move available that we haven't reckoned with. Maybe the universe is simply there, and that's the end of the matter. When is it's just there a legitimate stopping point? And when is giving up too early? That's chapter 4, and we'll get there next time. Until then, here's a question to think about. Be honest with yourself. Why do you prefer one thief to 12 conspirators? Is simplicity really a guide to truth, or is it just a preference for minds like ours? Because notice, if simplicity doesn't track truth, it's not just theology that's in trouble. It's every curve ever drawn through every data set. All of science with it. I'd love to hear where you land. If this is useful, hit subscribe. The series is just getting to the good part. I'll see you next time.